Everyone, my name is Jayanti and I am from Gokaraju Rangaraju Institute of Engineering and Technology and studying in Electronics and Communication Engineering. We have done a project on brain tumor detection using YOLO Wi-Fi and faster RCNN under the guidance of A. Sirisha, Assistant Professor. Our project is built based on a front-end and a back-end application. Front-end application is a login page. We have built a login page where the user can give input images and get output images as classified into glioma, and pituitary new tumor. How much region the tumor is formed, we can see and classify the tumor by seeing the image output images. And backend code is built with the Python, which has extensive libraries, and it is also known for deep learning. It also used for deep learning as it is a open source language. We have also used some extensive libraries like NumPy, Pandas, and for pictorial representation, Seaborn, etc. are used. And we have trained with certain algorithms, and we have got the validation scores and accuracy scores. Let us discuss in deep. Let us go to our problem statement. Um, Let us know what is the brain tumor is. We know brain tumor is a most hazardous problem in the world. A brain tumor is a mass or growth of abnormal cells in the brain. They can be either malignant or cancer. Benign. One can think what is benign and malignant. Here are the answers for that. Benign is non-cancerous and malignant is cancerous. So based on the size of the area and growth of the tumor, we can experience a severe headache, seizures, changes in vision, or cognitive changes. If we see a person suffering with brain tumor, immediately we have to take him to a doctor and treat him with a proper diagnosis. So doctor checks him and examine through some medical images known as MRI scans and CT scans. Even though MRI scans are known for medical images and medical diagnosis based, but some fault or false errors will be happened in doctor's statement. He may know the area where it is formed, but he can't know the what is the type of the tumor and how much area it is formed. So as to know the area and brain tumor region and also the type, we have developed a medical application known as brain tumor detection. So we have opted two algorithms which are known for deep learning based algorithms. So these two help us in tumor recognition and categorization. What are these two algorithms? Let us know. One is YOLO Wi-Fi and other is faster RCNN. YOLO Wi-Fi is a popular object detection model that belongs to the YOLO family of models. It designed for real-time object detection task and has gained attention for its accuracy and speed. It detects the tumor as a object. Here we are considering the area of the tumor formed as a object in order to find out through YOLO. And coming to faster RCNN. Faster RCNN is also a detection model, but it is different from YOLO. We can say it it predicts bounding boxes and probabilities indirectly one step. It proposes some region of interest and region pooling layer and refines the bounding boxes in those regions. It picks each region and classifies what it is, whether it is black, whether it is white, It can convert the image pixels into grayscale images and let know the tumor. So we can see some difference between this YOLO and faster CNN. So we can see the tumors. See, we can see a type of tumors here: meningioma, glioma, pituitary. So here our tumors are classified into four types. First, meningioma, glioma, pituitary, and then healthy tumor. So with no tumor, healthy brain we can say. So we we have gone through several papers and several projects, studied deep through and built this project. So in the existing methodology, we can say accuracy is slightly less, and some of the statements were wrong. It can be error prone, maybe. We can not say it will be wrong, but maybe it is wrong. So it can require some more of time. Here in the proposed methodology, we take input as MRI dataset and we pre-process the image where the image can be ready for the different types of methods like training, testing, comparing, like that. And then we have done data augmentation. Data augmentation is nothing but flipping the images, rotating the images, and in vertical direction or horizontal direction, reversing it, like that. We can see these images were taken from the Kakale website. So we achieved some accuracy better than the proposed, better than the existing accuracy, and also we require some less time compared to previous algorithms or previous methodologies. So we can see here we explore the data set and we can remove the null values. So input images are converted to black and gray images. We reduced the size of the images, level of pixels in the image. Then we done data augmentation for that, resize the image like training images, flipping, scaling, like that. So both the models are trained with the images. Here we can have some annotations for the images like um, some values, four values they have given, and we can consider the first value as 0, 1, 2, 3, 4. We can classify it as meningioma, glioma, pituitary tumor, and healthy tumor. So after it is important for every image to annotate, so that only we can perform YOLO, V5, training, and faster assembly training. So these both were trained. The images were what the data set we have taken was trained and tested. Our data set is about 200 of images, and we got several glioma tumors, minor glioma tumors, pituitary tumors. Here we can see how much the glioma tumors were present and how much healthy tumors were there. So we done some validation and confidence curves. Coming across all that, we seen some change in the accuracy. Here we can see the YOLO V5. It has some convolution neural network and it is for real-time objects with great accuracy. As I have said, we can see the architecture of the YOLO, and then we can see the faster RCN, and it is also a object detection model, and it contains region pooling layer. It extracts features from the region. How we implemented the faster RCNN for this project, we can see here. Next, coming to our results and discussion, we have gone through two training sets, and 80% of the data is trained and 20% of the data is tested. So we got some accuracy around 65%, and we observed that the YOLO Wi-Fi have scored more accuracy than the faster RCNA. Here we can see the tumors, different types of tumors, glioma tumor, and the area is also there 0.88, and many glioma tumors 0.58 something, and here we can see no tumor, as we can say it as healthy tumor, healthy brain, and here we can see pituitary tumor 0.86. It says the region, how much region it formed, and what type what type of tumor it is formed. So we can help the many people in fast aid and fast medical process with the better treatment after consulting doctor also. So here we think our project will be very helpful for the people who are suffering with brain tumor. For future scope, we are yet to decide with the new versions of YOLO or some advanced technologies like rather than choosing steroid CNN, we can choose mobile net unit, etc. Or we can take bulky data set and we can test on them and we can train them. For future scope, we are suggesting you to do on YOLO V8 and YOLO V7. Um, and that's a lot about our project. We can help the brain tumor people in faster recovery and a better treatment. I can see some hope how much the tumor is formed and also how much the area is there. The doctor can be more clear in order to treat the patient. So the doctor treats doctor treats the patient in a good way. So our project is helpful in that way. So thank you.